This is part 6 of section 5.2. We want to verify that sine of x plus y over cosine x cosine y is the same thing as tangent of x plus tangent of y. So let's take this left-hand side and use our addition formula for sine in the top. So we have sine x cosine y plus sine y cosine x. And this is over cosine x cosine y. Now if we split this up, into two fractions, our cosine y's cancel out here. We have sine x over cosine x, which is tangent of x, plus, and here our cosine x's cancel out. We have sine y over cosine y, which is tangent of y, which is our right-hand side. So this is proven. Okay, now let's find the exact value of an expression written like this. I want sine of the inverse tangent of negative 3/4 plus the inverse cosine of 4/5. Okay, well, this is essentially an alpha. I don't know what that angle is. And I can call this like a beta or an x and a y. So just ignoring this part for a second. This will be sine of two things added together. So sine alpha cosine beta plus sine beta cosine alpha. Okay, so let's figure out what we have going on here. We don't know what our alpha is, but we know that tangent of it is negative 3/4. Well, our inverse tangent is going to give us an answer in one of these two quadrants. And tangent is negative down here. So if this is my alpha, then this will be the point. Let's see, there's 4 and 3. Which of these is negative? Negative 3. Okay, so negative 3, positive 4. This must be a 3, 4, 5 right triangle. So sine of alpha is going to be negative 3/5. Cosine of alpha is going to be 4/5. Now let's do the same thing for beta. And inverse cosine will give us an answer here or here. And cosine is positive in the first quadrant. So I have, this is 4, this must be 3. So it's still a 3, 4, 5 right triangle, it's just in the different quadrant. So our sine value is going to be 3/5. Beta is 3/5. And cosine of beta should be 4/5, and it is. So plugging these values in here, we have negative 3/5 times 4/5 plus 3/5 times 4/5. And this is what, negative 12 over 25 plus 12 over 25. So this is 0. Okay, doing something similar here. Let's call this one x and this one y. So we're adding cosines. So I need to figure cosine x cosine y minus sine x sine of y. Okay, so if our sine is 3/5. Inverse sine gives us an answer in the first and the fourth quadrants, and it's positive, so it needs to be in quadrant 1. So this is 5, this will be 3, and this is 4. So it's the point 4, 3 up there. So it's exactly the same as up here. Sine, and this is my x. All right, so sine of x is 3/5. Cosine of x is 4/5. Okay, now for tangent, negative 4/3. Inverse tangent gives us an answer in the fourth quadrant because that's negative down there. And cosine is positive here, so let's see. That's going to be negative 3, this is positive 4, and this will be 5. Yeah. So, and this is my y, and this will be the point 4, negative, no, this should be 3, this should be negative 4. Sorry about that. This should be the point 3, negative 4. So sine of y will be negative 4/5. And cosine of y will be 3/5. So what do we have here? We have 4/5 times 3/5 minus 3/5 times negative 4/5, which gives me 12 over 25 plus 12 over 25, so this is 24 over 25. Okay, now one more type of problem. If the point AB is any point on the terminal side of an angle in radians that is in standard position, then for any real number x, A sine x plus B cosine x is the same thing as the square root of A squared plus B squared times sine of x plus theta. Okay, so let's talk about this. In this case, our A value is 4, and our B value is, this should be a plus, so negative 3. Okay, so that means that our point is down here. Okay, 4, negative 3. And so we need to figure out what this angle is right here. Well, one thing we do know is that tangent of theta will be negative 3/4. Okay, and then that means that theta is equal to inverse tangent of negative 3/4. And you can use your calculator to see that this is approximately equal to negative 0.644. Okay, and inverse tangent does give me the angle in this quadrant, so I don't have to worry about making an adjustment anywhere to get over to here. So one more part, we need A squared plus B squared. That will be 16 plus 9, which is the square root of 25, so it's 5. So how can I rewrite this in this form? Y equal to the number in front, which is going to be 5, times sine of x plus theta, which is a negative, so minus 0.644. Okay, similar problem here. Y is equal to 3 cosine x minus 4 sine x. This is tricky because your A belongs on your sine and your B belongs on your cosine, and they've got this out of order. So rewrite this as negative 4 sine x plus 3 cosine x. And that means the point negative 4, 3 is a terminal point on the axis. So negative 4, 3 will be up here. Okay, now I need to know what this angle is. And I know that in this quadrant, I need to find what my theta is going to be inverse tangent of negative 3/4. But this is going to give me the answer over here, and I need it to be over here. So I need to add pi to that. Now, you can use your calculator to get an approximation for this, and it is approximately 2.498. Our a squared plus b squared will be the same. It's going to be 16 plus 9 under the square root, so we still get 5. And so our answer here is y is equal to 5 times sine of x plus theta, which is 2.498.